Hey everybody, this is the video that I said that I would send to you on solving systems of equations. So let's do a quick review of that. This is something that you all should have been exposed to in the past. If you're struggling with it, you're going to need to do some research on it, or if you have to, you're welcome to text me and we will try to look at it together. But I think for most of you, it should be review. The times that we use systems of equations are when we have an equation or a couple of equations with more than one variable. And so we can't simply solve for the value of that one variable because there are two variables in the equation. So what we're able to do in that case is put together more than one equation to start eliminating one of the variables and then solving for the other variable. From there, we're able to plug things back in, plug the value of the one variable back in, and then we can solve for the second variable. So in this case, we could eliminate the y's, solve for the x, plug the x back in, solve for the y, and we end up with an answer that is an ordered pair, the x and the y. That's a solution to the equations. So that's what we're going to look at, but we're doing it in the context of our geometry. So let me adjust the camera just a little bit. And I know you have a glare that's a little bit challenging, but I think we'll be able to make it work. So here we have a diagram. And this is why we reviewed or learned vertical angles today, because both of the diagrams that we learned today are going to use vertical angles. Actually, the second one is going to use vertical angles. The first one, we have 90-degree angles. And I told you that whenever we have two intersecting lines that create one right angle or one 90-degree angle, all of the other angles around those two intersecting lines are also going to be 90-degree angles. We can view this, however, as vertical angles because these two angles are created by intersecting lines, and because they're across from each other in the intersecting lines, they are also vertical angles that are congruent. But in this particular case, we know that they actually each equal 90 degrees because one of the other angles equals 90 degrees. So we know that 6x equals 6x minus 2y is equal to 90 degrees, and we know that 3x plus 2y is also equal to 90 degrees. But like I said earlier, because each of these equations has two variables, we can't simply set one of them equal to 90 and solve. So what we're going to do is use both equations to solve here. So you'll see that I have rewritten one on top of the other, and I have done so in a way that lines up each of the variables and lines up the equal sign. So I have 6x minus 2y equals 90, and I have 3x plus 2y equals 90. I have lined up every part of it, and in this case, without having to do any additional work, when we add these two equations, we are going to eliminate the y variable because negative 2y plus 2y equals 0. So let's eliminate that part. And then we have 6x plus 3x equals 9x. And over here, we have 180. All right, now we can solve this like a regular equation. Give me just 1 second. I'm going to put my book closer so that I have it as a resource. So we have 9x equals 180. We're going to simply solve this equation. We're going to divide both sides by 9. And we're going to have x equals 20. All right, so we have our x equals 20 there. Now, we want to plug it back into one of the original equations so that we can solve for y. So I'm going to choose the top equation. The top equation, before I marked part of it out, was 6x minus 2y equals 90. I'm going to take my x that I have solved for, which is 20, and I'm going to plug it into this equation. 6 times 20, instead of 6 times x, minus 2y equals 90. 6 times 20 is 120. I'm trying to see if that's big enough for y'all to see. Yes. Minus 2y equals 90. Now I just need to solve this like any other equation. I'm going to subtract 120 from both sides. I'm going to have negative 2y equals negative 30. And y is going to equal 15 because I divided both sides by negative 2 and got, let's see, let me turn this, got y equals 15. So now what I have is an ordered pair Here is the first part of my answer, my x. Here's the second part, my y. And my ordered pair says that the solution to these equations should be 20 and 15. I can check that by plugging that ordered pair into one of the equations to make sure that it works. So this time, let's use the 3x plus 2y equals 90. I want to make sure that I stay within the window of what you can see. So 3x plus 2y equals 90. I'm going to plug in my x and my y. Here, did I write those down backwards? No, I did not. Okay, my x is 20, so I'm going to say 3 times 20. My y is 15, so I'm going to say 2 times 15 equals 90. And let's check and make sure it worked. 3 times 20 is 60, plus 2 times 15 is 30, equals 90. 60 plus 30 does in fact equal 90. 90 equals 90 on both sides of the equation, and we are good. So that is how we solve that system of equations. All right, now let's look at the second one, and I'm going to need to adjust right here so that you can see it well. And I'm going to quickly erase the first one while I talk. So the way that this one is going to differ from the first one is that this time we do not have variables that are automatically going to cancel out because of how the problem was written. So we're going to need to do an extra step of work this time to make it doable. And I'll show you what that means. All right, so first of all, what I hope that you see here with our two intersecting lines is that we do have vertical angles, of course. We're always going to have them when we have two intersecting lines. So these are vertical angles. That means they're congruent. And these are vertical angles. That means they are congruent. We also have several sets of linear pairs. So we have a linear pair here. That means they add up to, I want to give you a second to try to remember, they add up to 180. Remember, linear pair angles are supplementary. So this plus this equals 180. That makes this 108 degrees. Let me do my math really quickly and make sure I'm right. Yeah, okay, so we're good there. We also have a linear pair here. 108 plus this would equal 180. We also have a linear pair here. This plus this would equal 180. And lastly, right here, this is a set of supplementary angles making a linear pair. So 72 plus 5x plus 2y equals 180. But let's focus on what we can set equal in order to solve here. If these vertical angles are congruent, then we can say 2x plus 4y equals 72. You'll see that I have that written, 2x plus 4y equals 72. Our other set of vertical angles is right here. So we can set those equal, say 5x plus 2y equals 108. 5x plus 2y equals 108. Now you'll see that I left the 108 spot blank, and the reason for that is that in the beginning of the problem, we didn't have this piece of information. I did that as part of my problem solving. I said 180 for this linear pair of angles minus 72 equals 108. So I'm now able to put that in. But what you will also see is that I do not have variables that are going to cancel. These are not going to cancel, the x's, and the y's are not going to cancel. So I've got to alter part of my problem in order to make that happen. I need to multiply one of these equations by something that will make one of the variables in one of the equations cancel with the same variable in the other equation. I'm sure that sounds complicated, but I think you'll find that it's not as we work through this. So the first thing that I see that would be easy is that if I multiply this second equation by a -2, the whole thing, that means I've got to do it to both sides because whatever we do to one side of an equation, we also must do to the other. If I multiply this whole equation by -2, this is going to become a -4y. And then it's going to cancel with the positive 4y. Now, you may be thinking that was random. How did she know to multiply it by -2? All I did was looked at my options. Was there anything that I could multiply one of these by to make them cancel? Not easily. I would have to multiply both of them by something. But here, I could multiply this 2y by something easily, just simply a -2, to make it cancel with the 4y. So that's what you're looking for, is the easiest step to eliminate a variable. All right, so now because I'm going to multiply this, I've got to rewrite this problem. So I'm going to have 2x plus 4y equals 72 as one of my equations. 2x plus 4y equals 72. That's the top one. Now I'm going to do the bottom one. -2 times 5x is negative 10x. Negative 2 times 2y is negative 4y. And negative 2 times 72 is going to be negative 144. Let me make sure I'm on the right path with all of this. Yes. Okay. So when we do the math here, we are going to cancel 4y minus 4y is 0, so those are done. And what we have on this side of the problem, remember we're adding these two problems together. I should have shown you that first. So we added plus 4y minus 4y, that equals 0. We're going to add 2x minus 10x, that's going to be negative 8x equals, and then here we're going to add 72 and negative 144. No, I don't have that right. Hold on, I thought there was a problem. Y'all bear with me for just a second and let me see what I did wrong here. Oh, because I looked at the 72. Okay, I apologize. Let's go backwards for a minute. When I multiplied, and y'all probably already caught this, and I'll probably hear about it on Thursday, when I multiplied the negative 2 times the 108, that's what I meant to do. I actually looked at the 72 again. So I apologize, let's go backwards. I know y'all are catching that mistake. 108 times 2 is 216, so we're going to have a negative 216 right here. So now let's get back on track. We're adding 72 and negative 216, and the difference between those is negative 144. All right, so 72 plus negative 216 is negative 144. All right, now I'm simply solving. I'm going to divide both sides by 8, and I'm going to have x equals 18, and that 18 is positive because I divided both sides by a negative. So we have the x part of our problem. Now we need to plug it back in, and I'm going to adjust the camera to make sure that y'all can see everything. We're going to plug that x back into one of these equations. I'm going to use the 2x plus 4y equals 72. And because I know the x, I'm going to put it in the x spot. Plus 4y equals 72. 2 times 18 is 36. Plus 4y equals 72. We're going to subtract 36 from both sides. We're going to have 4y equals 36 and y equals 9. Now we have our ordered pair. Our x is 18. Our y is 9. Now, before I keep going, let me make sure I'm on the right track again because we don't need another mistake. Yes, okay. So this is our correct ordered pair, but we must plug it back into one of the equations just to be sure. So let's plug it into 5x plus 2y equals 108. 5x plus 2y equals 108. 5 times x is 5 times 18 plus 2 times 9 for our y equals 108. We're going to have 18 here. Let's see, what are we going to have there? 18 times 5 is 90. So we have 90 plus 18 equals 108. And that is going to be correct. Both sides of the equation are 108. And that is how you solve systems of equations. So we did one where we were given equations that already allowed us to eliminate, and then we were given one problem where the two equations did not give us the opportunity to easily eliminate a variable. So we had to go in and make a change. Let me adjust the camera one more time. We had to go in and make a change, and that change for me was multiplying both sides of the bottom equation by a negative 2 so that I could ultimately have a negative 4y here that would cancel with the 4y on top. So hopefully that helps. You can go back and rewatch this. I am getting this information from pages 152 and 153 in your book. They walk you through it very well. So that's another way to review this information. And then you will be doing numbers 1 through 4 on page 153 for your homework. All right, hope y'all have a great afternoon.